All right. So this is March 24th, and this is Calc 30. This is the worksheet. We just got finished doing number 1, working through number 1 as the initial sort of problem here, and this is what it looks like. Number 1. Just as a quick review, we have 1,200 feet of material. We should draw a diagram because in the question it says, what's the largest area for a rectangular fenced area that you can have given this amount of material? And so we drew a picture, and this was actually the answer at the end. We didn't have that on the picture. But we drew a picture and we said, hey, we need to maximize the area. So we wrote an area relation, an area equation there. Then we figured out that, hey, I need one variable only. So what other information am I given in the question? Well, that other information is the 1,200 feet of material. So that gives us another equation we can work with. From here, we solve for W so that we could insert this into this area function. And so that I have W equals 600 minus L. I have one variable in my area function now. Now it's a function of L. And in this case too, it might be a little easier to multiply this in so that you can use the power rule and sum difference rule versus the product rule, because sometimes the product rule is a bit tricky. Wouldn't have been probably any more difficult in this case. So we found the derivative, and we let that derivative equal 0 here, and I'll erase this too because that was some afterthought. But solve for L, and we recognized our critical number of 300. How do we know that that's going to yield a maximum or minimum? Two different options. You could factor the derivative, if that's easy to do, and put the factors here, do a little sign analysis. Put your 0 on there, do the signs. So we realize this was positive here before 300, negative after. And that gives us, which was sort of the focus of 4.3, we know that that's a local maximum. So that's going to yield us a maximum of whatever function we've done the calculus on, and that is the area function. So that's going to be the L value that's going to yield us the largest possible area. Another thing you could do, if this was difficult to factor, what you could do is use test points, and so that's sort of what I ended up doing here with these test points. We picked a couple points, one just shy of 300, one that's less than 300 in this area here, and plugged it in, and then you get a positive value right here for the derivative. If you chose 500, which is a little bit greater than your critical value, and you plug that into your derivative, you would get a negative value. So you don't have to do sign analysis, you can use test values. And this was really nothing. That's just another little explanation of the test value situation. Okay, so now we're up to, let's do another one. Which one do we want to do here? Find the area of the some of these, I'm not going to get you to do all of them because some of these are a little bit above you. This would be a university worksheet for sure, I think. But, oh, okay, well, let's do number 2. This is a reasonable question here. And the number 2 says, suppose the man in the previous problem uses a building in place of one of the sides of the rectangle. What should the dimensions be now to enclose the largest possible area? So what's changing? We still have 1,200 feet of material, okay? But what's changing is that material is only going to be used for 3 sides, not for 4. Okay? So if this is the barn here, right, that's going to be one side of the rectangular pen. So now I can actually make quite a bit of a bigger pen, as you can probably understand, and larger area, and so, because I don't need to use this material for this side. So we still want to maximize the area. So, you know, if we have, let's make this the width, and this is the length, we still have area is the width times the length. But I only want one variable, so just as in the previous question, let's use what information we're given, 1,200 feet, and the fact that this is the shape, and this is how we're going to use the fencing material. So we say that W plus L plus another W, another width, because this is rectangular, so these two are going to be identical, equals 1,200. So notice in the previous question we used 2 L's and 2 W's that were adding up to 1,200, but now we only use 1 L because the barn is the other length. Good with that? So this is going to change a little bit what our variable is. So now L is going to be 1200 minus 2W. So I would suggest let's replace the L with a W. And so this is going to be a little bit different than the last question in that we're going to be working with the other dimension, but that's no problem at all. So this A now is going to be a function of W, and it's going to be W times, I'm going to substitute this in right here for L. 1200 minus 2W, right? Everybody good with that so far? So this is going to be a little bit different, right? It's not the 600 here. So the derivative of that, well, I guess first we probably could multiply this out like we did last question. So that's actually 1200W minus 2W squared. That is going to be easier for us to work with. The derivative, 1200 minus 4W. Everyone good with that? Okay. Okay. What I'm going to do here now is I'm going to give you just a minute. I want you to finish this. Just do what we did for that last question. Take a moment and finish this question, and I'll show you the answer in a minute. All right. So what we wanted to do here is we wanted to take the derivative of this 1200 minus 4W and set that derivative equal to 0 and solve for W. So W gives us a critical number, right, of 300. To solve for L, you just go back and you say, hey, what was the relationship between W and L here? Right, this equation right here. So L is 1200 minus 2W. You plug that in, you should get 600 for L. Is that what you guys got? A width of 300 and a length of 600. Okay. So if they're asking you for the area, okay. So these are the dimensions right here. You would say your answer would be the dimensions. Is it? All right. The dimensions that yield the largest area are 300 by 600. The area, you should put the area, remember I mentioned yesterday, so the area is 880,000, right? Square feet. All right, so dimensions 300 by 600, and this is your largest area. So just make sure that adds up, and of course your check could be, does this add up to 1200? So 300 plus 300 plus 600 should equal 1200, and yes, that's true. Okay, so any questions about that, any issues with that one? All right, so on that calculus worksheet, we will do questions 1 to 7. And I've done 1 and 2 with you here, so we have the rest of the class to work on that.